Alright, welcome back to our series on creating generative sequencers in Reaktor. Previously, we were working on a rebuild of an old ensemble of mine, and we're going to keep on working on that today. And what I have on the screen in front of me now is it's going to be pretty close to the end product that we get today. I'm going to try to get all the stuff that's on screen now implemented today. We might not get there, but we'll try. And so basically, we've added some scales to the ensemble. So you can now select a key and a scale, and then there's a series of sliders at the top of each column here that is going to allow you to select a note within that key. And then when we have a collision at the edge of one of those boundaries, we'll end up triggering the note that's been selected by the slider, and we'll end up with something that is a little bit like this. Alright, so these guys will pretty much keep on bouncing around forever, and whether or not they ever repeat kind of depends on how you set it up. Jumping back to our work from the previous video, I'm just going to make a few macros invisible here that are on the screen. And one thing you might have noticed about our quote-unquote finished product is I got rid of the size Y knob. I just replaced it with the size X knob, so anything that's connected to the size Y knob can be connected to size X instead. And the reason I did this is originally I thought I wanted to be able to control the number of rows and the number of columns separately. And I still think it would be kind of cool to do that, but in terms of the graphic user interface, it just kind of turned out to be a mess to program, and it's a lot easier just to go with the one knob that controls the size of the grid, so I'm going to do that for now. Alright, so in the previous video, we figured out how to add different types of nodes to the grid. You could cycle between 4 different colors that are eventually going to mean 4 different directions. And we ended the video right as we were getting into making the active nodes on the grid move around. And so that's what I want to start doing now. We created this advance macro. Every time it receives an input, it triggers all of the nodes in the grid to move forward 1 square. And so the first thing I want to do is connect that to the core cell, and then we're going to create a new macro that is going to trigger our advance macro. And this new macro is going to consist of a song position module. And we're going to take the output, which is in 96th notes, which means we get 96 of them for every bar. And we're going to end up moduloing that against another number that is going to determine the speed at which we're triggering the grid to move forward. So we're going to divide and drop the remainder using the div output. And we're going to send that to a router. And the router is only going to let events through if the start-stop clock is on. So if the MIDI clock is on, then that means the clock is running, we're getting new events, all is well and good. If this clock is stopped, the song position could still change. The user could be moving around the song position in their DAW or whatever, changing the song position, which if we didn't use this router here would be, triggering new events to happen, which would be kind of weird and unpleasant. So we're just going to stop that from occurring. I'm going to take the output of the step filter and or the router and send it to a step filter. So these events are eventually going to go and trigger the iterators within the advanced macro that we created previously. So I want that value to be equal to 0, so I'll use a value module to trigger that. Although actually, I think we already have the value modules inside the advanced macro. If we hop inside there, yeah, all the numbers are getting set to 0 anyway, so we don't need this. We're just going to send any old event on in. And the next thing I want to do is we need to choose a number that we're dividing our song position by. So our song position is in 96th notes. So there's going to be 96 of them in every bar. So I'm going to add options for 32nd notes, 16th, 8th quarter, half notes, and full bars. And obviously you can add more than this. So if we want a full bar, if we want a new event for every bar, then we're going to divide this number by 96, right? And it's going to go up by 1 every time we get 96 new notes, or 96 new events. So similarly, a half bar is going to be equal to 48. A quarter bar will be 24. So we're just taking 96 divided by 4. 96 divided by 8 is 12. 96 divided by 16 is 6. And 96 divided by 32 is 3. All right. So those are the values that we're using to control the speed of our advanced clock, and I'm going to name this macro generator. So it's generating new events to advance our grid. All right, so inside our core cell here, we're going to get 3 new events every time we get 3 new sets of events every time we get a new advance event. We're going to get a series of events to clear out one of our arrays that we're going to use to hold data in, and then we're going to get another series of events to move our existing nodes to their new positions within the array that we just cleared, and we're going to get a third series of events that lets us copy the array that we've been using back to our main array. So our clear events come in and they clear out our array down here. And then our move events come in. We are reading out the existing grid and checking for the various values that could exist in that grid. So remember that each cell can hold multiple nodes at one time. So we're checking for the up node, the down node, the left node, and the right node all at the same time. So let's give us these 4 events here. And so basically we want to, those events are telling us, hey, there's a node to be moved in this cell. So we're going to take the position of that node and change it and store it within the array that we just cleared. All right, so we're storing the move index in a latch, and then the latch gets triggered by, say, the move up quick bus. So what this is telling us is that there is a node moving upwards in this particular cell. Now to move upwards, remember our grid is a maximum of 32 by 32 across, so moving up is the same as adding 32. So the bottommost left-hand corner is grid 0, and then 1 up from that is 32, 1 up from there is 64, 96, etc. So when we want to move upwards, we want to take our value and add 32 to it. So I'll create an x plus a macro and add together like this. The other thing to keep in mind is when we reach the top row, we want to turn around. And so we need to check if our new position that we've just calculated has gone too far. So I'm going to create a new macro to do that with, and it'll have one input from our x plus 32 module here. And we're basically going to check to see if our y position has gone too high. So we're going to take the input and we're going to do a div mod by 32, and the div output is going to tell us the y position of our current grid cell that we're reading from. So we're going to take this value and we're going to compare it to the size of our grid, which is stored in a distribution bus. So we're going to put position Y in the bottom half, and then we're going to type in our distribution bus, pick up distribution bus size Y. So if our size Y is larger than our current position Y, then we're fine. Nothing to worry about. And if not, then we actually need to turn this node around. We need to change it from moving upwards to moving downwards, and we need to change the grid as well. We want to subtract 64 from the value in that case, because instead of moving up 1, which we've already done, we want it to be moving down 1. So we need to move back down the 32 that we've already gone too far, and then back down another 32 to actually move downwards. So we're going to take the value and subtract 64 from it. Now coming out of this this macro, we get two outputs. They can both be sent to quick buses. The first one can be named, say, up index, and then the second one I'll name up reverse. So the first one just says, hey, we have a new, we want to store a node moving upwards in this index. And the other one said, well, we were moving upwards, but now we reversed. And so that's going to trigger a MIDI note and do some other stuff as well. I'm going to duplicate this whole setup, and we're going to change things around for moving downwards. So first of all, we're going to trigger this latch using move down, and then we'll change our quick buses at the end to down index and down reverse. Instead of adding a value of 32 to move downwards, we subtract a value of 32 to move downwards. And then finally, we need to go into the macro itself here and change some things up. First of all, if we are changing directions, instead of subtracting 64, we're going to be adding 64, because instead of changing from moving up to down, we're changing from moving down to up, so it's the we also want to make some other changes here. So basically, we're just going to compare the input to 0 here, and if the input is greater than or equal to 0, we're fine, because the bottommost row is always the row from, with node values from 0 to 32, grid cell values from 0 to 32. So as long as we're greater than or equal to 0 here, we should be fine. And we want to just add 64 for reversing and do nothing if we're just letting the value pass through here. All right, so that's how to move downwards. And so next we need to check out when we're moving left if we've gone too far. So I'm going to duplicate one of these existing setups we have here. And once again, we can change around all the quick buses and all that stuff. So we're triggering this one using the move left quick bus. We're going to change the name of our output quick buses here. So the left index I've already used. All right, I'm going to change this over here to left click instead. So these are the ones coming from the mouse area. So left click and right click, and that way we'll have some quick buses opened up for left index and right index. All right, so we got our left index and our left reverse here, and we want to, when we're moving left, we're subtracting 1. So moving to the right, we add 1, 0, 1, 2, 3. Moving to the left, we subtract 1, 3, 2, 1, 0. So instead of adding in a new subtract module here, we just add -1. Same thing. All right, so then moving to the left, what we're going to do is we're going to check the X position of our grid cell using this div mod solution again. So this is just going to give us the X position and the Y position, and we're going to say, well, if the X position is equal to 31, that means we just wrapped around from one side of the grid to the other. If the x position is equal to 0, that means we're at the leftmost side of the grid, and if we subtract one more from that, then our x position ends up wrapping back around to the other side, becoming the maximum value it can be, which is 31 in this particular instance. When we're using a div mod by 32, the x outputs are going to range from 0 to 31. So we're going to say as long as x isn't equal to 31, we're fine here. So if x is equal to 31, we're going to add 2 to the position. So we subtracted 1 from the position to get where it is. And if we're saying, oh no, that's not actually a legitimate place for us to be, then we need to, add back the one that we subtracted. And then we've also changed direction, so we'll add another. So add 2 and done. All right. I think we actually are going to have another corner case to work out here, where if x is equal to 0 and we subtract 1 from it, then the div mod method doesn't work. So we need to also check if we've gone negative, actually. But let's get everything working before setting that up, because I'm actually not sure if that was the problem or not. So let's save that for a later date here. And for now, let's make the move right method. So again, switch up the quick buses. This one's triggered by move right. The outputs are going to be right index and right reverse. And instead of subtracting 1, we're going to add 1 to the value. And this time, to check if we've gone too far, we just want to make sure that our position x does not equal 0. Because that means that we've wrapped around too far from one side to the other. And then the other thing to check is that our position x is not larger than our size of x, or equals. So as long as those are not equal to each other, alright, so we'll take the top output here, is the one that survived both of our conditions, and then the other two bottom outputs can be merged together, and those are both of our failed conditions that change the direction of this node. Alright, so at this point in time, we have determined all of the new positions of our nodes, the ones that are moving up, down, left, right, and the ones that have bounced off the edges have all been taken into account. And now we need to write those values into the array that we've created. So we have an array at the bottom of the screen that we've already cleared out using the clear index quick bus, and now we need to store these values that we're creating in that same array. And so what we're going to do is, we know the index that we want to write to, so we're going to read any current value that might exist in that index, because remember, we can store multiple nodes within any grid cell, so there could already be something there, even though we've just cleared it out. One of our other move events could have moved something into the cell, so we want to check if there's something there. We're going to read out what exists there, and we're going to add to it this new event that we've created. In this particular, using the move up index to read out, that means we have a new up node entering this position. So we add 1 to the value. We've already created a quick bus named up that holds this value, and we'll store that in the up index. So we basically took this index, it's, hey, there's a node moving upwards here. And then we're going to do the same thing, but we're moving downwards this time, so we're going to use the down index. And we're going to read out from wherever anything that was moving down ended up. This is the new index. that's receiving a new down value. Alright, so basically every time we're reading out the index that we've determined our node is moving to, and then we're adding a power of 2 to that value that is denoting that type of node exists in this cell. So keep on keeping on. This one is moving left, so we add the left quick bus and use the left index. And we have one more quote-unquote normal right function to add here for when we're moving right. So we have the right index, and we're going to trigger the add module using the right quick bus. And then we also have to use all the ones that are bouncing off the walls. The up reverse, down reverse, left reverse, and right reverse can also all be filling cells up, just moving in a new direction. Alright, so we can just copy and paste this little bit of code here where we read out from an index, add a value to it, and then store it back at the same position. I'll just duplicate all 4 of these, and then what we need to change is the quick buses. So we also want to store values when we have an up reverse function. So we take all the instances of the up index and replace it with up reverse. And when we've reversed a signal moving upwards, it's now moving downwards. So instead of moving a value of up, we'll add a value of down. And we'll go and do the same pattern. So we'll take the downs. Those are now going to become down reverse. And when we've reversed a node that's moving downwards, it's going to be moving up. So we take the left index and we replace them with the left reversers. And then instead of adding a node moving left, we add a node moving to the right. And then finally, we replace the right index with right reversers. And then when we've reversed a node that's moving in a rightwards direction, then it will now be moving left. So this is all fairly, abstract and complicated, I imagine, but it definitely took me a while to figure out how to work in this sort of an abstract manner inside of Reaktor. But it is substantially more efficient, I believe, than my previous setup, which was kind of hellish to design. So I think this one is much simpler than the old ensemble that we are working to replace here. Alright, so we cleared out our temporary array. Then we use the move index events to fill it up with the current indices of all of our nodes. And now we want to use a third set of events to read our temporary array back to the original array. So I'll create a read macro for this purpose. And I think we'll just wire it up. I don't think it really matters which OBC connection it gets. Kind of awkward kind of an awkward positioning for all of these objects, I feel like, but other than that, it should be fine. So we're going to use the finish index to read out of here. And then the value coming out is going to be the finish value. And this value can be written to our original array. So we'll want to create a new write module for that, write macro for that effect. It's going to be written to the finish index. We're going to write the finish value to the finish index. So at this point in time, I think we should be able to create some nodes on our grid and click the MIDI play button and have some stuff move around on the screen. It's not going to trigger MIDI notes yet. They aren't going to collide off each other properly yet, but they should bounce around, and everything seems to be working. So if we change everything to move left, right instead, let's check those out as well. Alright, so we got our different nodes bouncing around, and the edge conditions appear to be working. As I mentioned earlier, I think there is one towards the bottom here that won't work. So if we go left from here, I think it just disappears. Yeah, so we want to change that as well. We'll go into the move left array here, macro here, and we just want to check that our value is greater than 0. Whatever it happens to be has to be greater than 0 in order for stuff to work. So I'm going to compare greater than or equal to 0. And if so, then we can let it pass through, and otherwise we change directions. See, I noticed this bug in my practice code and never bothered to solve it, but I think this should fix things. Alright, so once we have this looking some semblance of clean, then we can hop back to the panel view and try to get a good look at whether or not things are working. Alright, so now we have our edge collisions working properly, and the another thing I want to add here, though, is we can have nodes colliding with each other. See, they both occupy the same position at the same time, and it's kind of particularly ugly right now. They just draw a black square. So I'm going to go into the RGB values here, and we're going to spruce those up a little bit. So basically, our RGB tables here, they store values for any of the existing node types, which are equal to values 1, 2, 4, and 8. And everything else is just showing an RGB values of 0, which turns out to be black. So I'm just coming in and I'm filling in all of the empty values with values of 0.9, which will be like a very, very bright gray, pretty close to white. So anything that's not in indexes 1, 2, 4, or 8, I'm changing to 0.9 here. And so if our node is equal to 1, that means it's moving up. If it's down, it's equal to 2. If it's left, it's equal to 4. And if it's right, it's equal to 8. And then so any other number, like 3, is a combination of those two. Like it's 1 plus 2. 5 is 4 plus 1. 15 is 8 plus 4 plus 2 plus 1. So any value that's not equal to 0 and not equal to a power of 2 means that there's a collision happening in this index. Oh, and I must have changed one of the colors, because now the upwards moving ones turned yellow instead of red, which means I added green to the setup. So let's go in and change that. Change the green. Oh yeah, there it is. Back down to 0.1 or whatever. All right, so now when we have a collision happening, you see there kind of this bright white color on the screen. It's a little easier to see, and nothing's happening during the collisions yet. So that's the next step that we want to take, is switching up which direction things are moving when two objects collide. So basically we have our finished value, which ranges from 0 to 15 and tells us which type of nodes are currently active in this index. And we're going to read out another value that's also going to range from 0 to 15 to replace our original one. So first of all, we're going to leave certain values alone. Like if there's a value of 1, we'll leave it alone. 0, we'll leave alone. That means there's nothing here. 1 means there's one moving up. We'll leave that alone. 2 means there's one moving down. We'll leave that alone. 3 means that there's one moving up and one moving down. We've got a 2 plus 1. So we want to change that to one moving left and one moving right. So that would be 8 plus 4, which is 12. So we have a value of 3 in, we're going to have a value of 12 out, and it's going to change the direction of both of our nodes. 4 in, 4 out. 5 is equal to 1 moving left and 1 moving up, and we want to change that. We want 1 to be moving down and 1 to be moving right, which is going to be a value of 10. And so moving on, 6 is going to be 4 plus 2, and we're going to change it to 8 plus 1. 7 is equal to 4 plus 2 plus 1, and we're going to change that to 8 plus 2 plus 1. 8 we leave alone. 9 is equal to 8 plus 1. We change to 4 plus 2. 10 is equal to 8 plus 2. We're going to change it to 4 plus 1. And so on and so forth. So basically, these numbers took me a while to figure out. It was a bunch of trial and error and seeing how things collided off each other and what sort of patterns they made and kind of making a choice. So basically what's happening here is if you have one moving up and one moving down, they both get changed to moving left or right. Similarly, if you have ones moving left and right and they collide with each other, then they both change direction and one moves up and one moves down. So basically we've tried to make it so that as many nodes change direction during a collision as possible. If you have a total of 3 objects colliding with each other, then when they've all changed directions, one of them is going to be moving one of those original 3 directions no matter what you do. So it's not going to be perfect, but it works. Alright, so again, we use the finish value to read out from this table, and then the value coming out of this table becomes the new finish value. Super simple, and this allows us to rewrite the value of any node to any other node. Now we should be able to get collisions. See our nodes bouncing off of each other. Alright, so this video is getting pretty long, so I'll probably split out today's work into another video. Thank you guys for watching. Next time we'll start setting up triggering MIDI notes, and I'll see you there shortly.